And we're on lesson 86 now. We're talking about the volume of pyramids and cones. And your objective is listed right here. Make sure you get it written down. First thing we're going to do is give you the volume formula for pyramids and cones. And it looks like this. 1/3 times the area of the base times the height. Okay, and again, I said it right there. This means the area of the base. Okay, so 1/3 times the area of the base times the height. Okay, or we can take the area of the base times the height and divide it by 3. That's how we find the volume for pyramids and cones. Okay, now let's go ahead and use this formula in some examples. Okay, we've got a word problem here. It says Aiden built 2 cones out of sand on the beach. The diameter of the small cone is 6 inches and its height is 5 inches. Okay, the diameter of the larger cone is 12 inches and its height is 10 inches. How many cubic inches of sand did Aiden use for each cone? And then, how many times greater is the volume of the large cone than the volume of the smaller cone? And it says to express pi as pi. So instead of multiplying times 3.14, we're going to leave it, okay, as pi. And we have diagrams of the 2 cones here. And this is the smaller cone that he drew, so it's a good idea to draw a picture. Okay, now how do we get a radius of 3? Okay, well, if you read here, it says the diameter of the smaller cone is 6 inches, so they put the radius of 3 inches here. And the reason that they did that in their drawing and marked the radius instead of the diameter is because our bottom of a cone is a circular shape. Okay, and when we find the area of the base, when we find the area of the circle, we need to know the radius. So instead of marking the diameter, it's a good idea to mark the radius when we're talking about circles anyway. Okay, then here, the bigger cone, it says the diameter was 12 inches, so that means the radius is 6 inches. Okay, so this is a 6-inch radius circle. Now, we want to know how many cubic inches of sand did Aiden use for each cone. Okay, so cubic inches means to find the volume. So we want to first find the volume of the smaller cone. And again, the formula for that is 1/3 times the area of the base times the height. Okay, so we're going to take 1/3 times the area of the base. Well, the area of the base is pi times the radius squared. So we're going to take 3 squared times pi. And we're going to multiply that times the height, and the height is 5. Okay, so again, right here we've got our 1/3. This is the area of the base right here because the area of the base is pi times radius squared. So we're taking our radius squared, multiplying it times pi, and we're leaving it in terms of pi because it says so right here. And again, times our height. Okay? Well, we got 1/3 times 3 squared is 9 pi times 5. Okay, well in this case it's easiest to do 1/3 of 9 first because 1/3 of 9 is 3. So we're going to have 3 times pi times 5. And then we can multiply the numbers together. 15 pi is the volume of the small one. And that's in inches cubed. Okay, so that's one answer because it asks for the volume of each cone. So there's that one first. Now we're going to go over here and we're going to find the volume of the large cone. And again, the formula is 1/3 times the area of the base times the height, which in this case is 1/3 times the area of the base, again, is pi times the radius squared, so we're going to do 6 squared times pi times the height, which is 10. So it's 1/3 times 6 squared is 36. I'm going to do the 1/3 of 36 part first. Okay, because 1/3 of 36, that means 36 divided by 3, that's 12, times pi times 10. Okay, well 12 times 10 is 120 pi and that's in inches cubed. So that's the volume of the large cone, 120 times pi inches cubed. Now, the last part of our problem said how much larger is the volume of the larger cone than the volume of the smaller cone. So how many times bigger? Well, to do that, we've got pi times pi here, so those kind of cancel themselves out. So what we're going to do is divide, okay, to find out how many times bigger. So we're going to take the volume of the large cone divided by the volume of the small cone. Okay, and the volume of the large cone is 120 pi inches cubed. The volume of the small cone is 15 pi inches cubed. So our inches cubes cancel, our pi's cancel, so we just need to do 120 divided by 15. Okay, and if we do 120 divided by 15, we're going to figure out that is 8. Okay, because 8 times 5 is 40, and then we carry our 4, and 8 times 1 is 8, plus 4 is 12. Okay, so it's 8 times larger. Okay, 8 times larger. And the reason for that is because if you look at this, these two cones, okay, the radius is doubled and the height is also doubled. Okay, so the cone itself, okay, the parts of the cone are 2 times bigger. And since it's cubed, when we talk about volume, means 2 times 2 times 2 times bigger. That is 8. Okay, so 8 times bigger total. Alright, let's go on to some more examples here. Okay, example 2 says to find the volume of this square pyramid. Okay, so again, first thing we need to have is the volume formula. And the volume of a pyramid is the same as the cone. It's 1/3 times the area of the base times the height. Okay, so we're going to take 1/3 times the area of the base. So the area of my base, which is a square, I find the area of a square by taking a side times a side. Okay, in this case, since the sides are the same, it's 90 times 90, or 90 squared, times height. Whoops. Instead of height, sorry, we know what the height is. They tell us the height right here. It's 50. Okay? So we're going to take 1/3 times 90 squared, that's 90 times 90, that's 8100, times 50. Okay? So again, we could take these big numbers and multiply them together and then divide by 3 at the end, but since I'm pretty good with fractions, I like to do 1/3 of whatever this number is first. Okay, and I know that 1/3 of 81 is 27, so then 1/3 of 8100 should be 2700. Again, if you're not good with fractions, you could take 8100 divided by 3, and that's what it'll give you. Okay, so then we need to take 2700 times 50. Put a 0 here, 0 here, 0 here. That's 35. Carry the 3. And 5 times 2 is 10. That's 13. So it's 135,000. And we're going to put centimeters cubed as our label. And it's cubed because it's volume, okay, to the 3rd power. Okay, so there we go. That's how they find the volume of a pyramid. Again, it was 1/3 times the area of the base, and since it was a square, we just take 90 squared for the area of the base, and times the height, and we multiply everything together. And let's move on to our last example. Example 3 says a triangular pyramid is shown. The area of the base is 36 times the square root of 3 units, and its height is 10 units. We want to know what is the volume. So again, the volume of a pyramid is 1/3 times the area of the base times the height. So in this case, it's 1/3 times, we know the area of the base. The area of the base is 36 times the square root of 3. Okay, they told that to us right there. The area of the base is 36 times the square root of 3. And we know the height is 10. Okay? Well, we notice we got a square root in here. Don't let that fool you. We've dealt with these before. Pretty much, we can multiply all the numbers together that are not underneath a square root. If there were numbers in a square root, okay, like say this had a square root of 3 on the end of it, we could multiply those numbers together too. But since there's no square roots, we have nothing to multiply this by. So we're just going to leave this, okay, until the very end. So the very first thing I'm going to do is 1/3 of 36, or 36 divided by 3. That's 12 times the square root of 3 times 10. Okay? And again, we got numbers on the outside of square roots here. 12 times 10 is 120 times the square root of 3. Since one of these is not in a square root and the other is, we can't multiply those together anymore. Okay, so now what we're going to do is put a label on the end of it. And this said the base is in units, so we're going to put units cubed. So it's 120 times the square root of 3 units cubed. Okay. Now if it told us to approximate that, okay, then we could use a calculator to figure out what this is in decimal form. Alright, and then go ahead and multiply it, but it doesn't tell us to approximate, so this is the best, most exact answer that we can give. Okay? And that is all for your lesson on how to find the volume of cones and pyramids. Best of luck to you on your homework.